Good afternoon once again. You're welcome to our center, Physics Calculation Center. Today we'll be looking at a different topic from what the topics we've been looking at. We'll be looking at work, energy, and power. Work, energy, and power. Work. I want to define work for clarity's sake. Work is defined as the product. Work is defined as product of force and distance, the product of force and the distance in the direction of force and the distance in the direction of force. Beautiful. In the direction of force. So we can simply put it as work done equals force times this distance. Force times distance. Force times distance. Which we can mathematically put, or using notation, F for force and S for distance. So this is work done. And it depends, since distance can be height also. Distance can also be height. So we can write this to be F times mg, because it has to do with height. So we can write that to be force times mg. Okay, or sorry, mg times distance, because force is mass times acceleration. So we can do this, it's also the same thing. Force is mass times acceleration or gravity. So if you do mg times distance, it's same thing as work done. What is the unit for work done? The unit for work done is in joule. Unit for work done is in joules. So we call it joules. Any calculation you do in physics and it has to do with work, it's always in joules. Okay. Now, another thing I want you to know is that this is work in one direction. Now, work can be in different directions. Now, let's look at this. If the force is applied at an angle, you can apply force. If force is applied at an angle, theta to the horizontal, okay? It's applied theta to the horizontal, okay? I just show you. The work depends on what direction the object moves, yes. So the work done depends on the direction the object moves. So you can have something like this, okay? Now this is moving, so this is the resultant, and this is theta, okay? And the force, this is the force, okay? So we have the horizontal direction. So if it's horizontal, it is F cos theta, and this is horizontal, okay? So that's the direction it's moving, okay? So let's say this is the object. The object is somewhere here in the box. That's the object, okay? So if the box moves horizontally, so let me just put that. Therefore, if the box moves horizontally, the work done will be equals to F cos theta. If the box moves vertically, box moves vertically, work done will be equals to F sine theta, times distance, F sine theta times distance. The work done will be that. Okay, beautiful. You can see, and I told you, work is measured in joules. So quickly, I'll run over this. We know work is defined as the product of force and distance in the direction of force. Now, work done is force times distance. Force times distance. Force can also be mass times gravity if it is falling freely under gravity. If it's accelerating on a straight line, use MA. The unit for work done is in joules. If force is applied at an angle, now sometimes you do some work at an angle. So if it's horizontal, it is F cos theta. F cos theta. But if the force is vertical, you use F sine theta. So instead of doing F times distance, you do F cos times distance, F sine theta times distance. And this gives you what you need. In our next video, we'll be looking at energy. Thank you.